So we've seen how to use XMLHttpRequest to create asynchronous interactions with our server side. And this is a really powerful tool. However, if you remember in previous conversations, we said that early days JavaScript was not very robust or complete. One of the biggest examples of this in real life came about because of the proliferation of applications using XMLHttpRequest. This library was pretty poorly written and it was a little hard to use. So what happened in response are a lot of library softwares like jQuery that were intended to wrap this functionality in a much cleaner and easier to use method. This went on for a long time, in fact so long that jQuery is still today very commonly used by teams who have been using it for years and by much legacy code that has it so intrinsically built into it that it would be hard to wedge out. That said, we mentioned that in the last half decade or so, JavaScript has been really evolving. And one of the ways it evolved is to add the fetch library and the promises API. These allow us to have a better way natively right within JavaScript to manage asynchronous requests. They largely replace the need for any external libraries like jQuery because they can do the job as well, if not better, than you can do with jQuery. And they completely eclipse the need to use the old XMLHttpRequest APIs. The promise is the other piece to this that we're going to want to understand. A fetch is basically asking for something asynchronously from a URL. A promise is the wrapper that we're going to use around the asynchronous option that that allows us to manage it nice and succinctly. Basically, we're going to give it a URL as a parameter, and what I'm going to get back is a promise. A promise is this wrapper that I have a then method on. The then method takes two parameters, which I am going to pass it. You don't have to pass two, you can actually just pass one, but you can pass up to two. The first method is always the success, and if you send another method, it is a failure method. This might sound very weird at this point. It's one of those things that is easier to understand once we can show it, so I'm going to jump into that part now. So here is what a fetch call looks like. You can probably see already that this is a much cleaner syntax than worrying about using an XMLHttpRequest. We're designating here that we're doing a fetch, and here is the URL that we want to fetch, our original AJAX info.txt from the previous video. This promise here now is what's going to be returned from this fetch. So the object that's returned from the fetch is the promise. The then method on the promise takes up to two parameters as parameters. It takes a success function and a failure function. And remember, this failure function here is optional. You don't have to provide that. These are the things that will happen if this is successful or if it fails. So let's build this out now with a little bit of actual code. So we have the same fetch here, grabbing the same file. This again is going to return a promise. We have a then method attached to that promise with the success function here. So the function now takes in its own parameter. The success function is going to be passed a response by the promise. So again, here's our promise. This then method is a method on the promise. The then method takes in a function you will give it to run as the function to run on success, and it will pass your function the actual response that it gets. We can then take that response in our function and use it to, say, get the text out, which is what we wanted, right? So here we are grabbing the text out of the response, and now we have another then. Why? Well, just to make things fun, but no, that's not really why. This is another promise. Why is this another promise? Because it's an asynchronous action. Text, remember, requires I/O. I have to go and grab this stream of bits that's coming in. I don't know how long this stream of bits is going to be. I don't know how long it's going to take for it to all arrive. So I have to say, when it does, then call another function that I am passing in as a success function. So what is my function getting this time from the promise? Well, it's getting the data. It's getting the contents of the text in the response that I was requesting. So once again, there's two promises here. There's one promise for the actual HTTP asynchronous request. And when that returns, I pass a success function, which is passed the response by the promise. Inside my success function, I am now returning another promise. I'm asking for the text from this response. Again, this is asynchronous. I don't know how much text is here or how long it will take to traverse the bit stream. So this promise now has its own then method for when it's complete. I give it a function I want it to run when it is complete, and it passes me the data that it retrieved from the text. I can now use this data to alert success. Notice here too that on the first promise, I actually have a failure function as well. So here's my first promise, the fetch. Function 1 here is success. Function 2 is failure. Note that we did say failure is optional. That should always be the case, shouldn't it? We did say the failure function is optional. So in this second promise, if you note, there is no failure function. I only have a success function. I could have a failure function here. That would be fine, but I don't. This is a failure function for this first one. On failure, I'm going to just console.log out that there was a failure so that I could look forward in my log if something went wrong. You can do whatever you want here. There might be some bookkeeping kind of stuff to do to make sure that your app is clean, or maybe you have to make a new request, or maybe you have to save something. Whatever would need to happen, you can use this space to make it happen there. All right, so remember in XMLHttpRequest, we were looking at the status of the request to decide when and what to do. Well, we can still do that here if we want to. So we still have the response, and we still get to use the status on the response. And in this case, we're looking to see, is this anything other than 200? If so, then we're going to console log out whatever the message is in the response.value. Because if it's like a 500 something or a 404, we'll get that information now in our log. Otherwise, we'll assume it was a 200, which means it was a good and happy request. And then we're going to here get our promise on our response text, have a then method on it, and call our function that we pass in. It will provide our function the data, and then we're going to change the inner HTML of this game controller object to the data that we retrieve. All right, just to review this again, because it is a pretty kind of mind-bending concept when you first hear it. So it's one of those ones that repetition is honestly really good. So how do we create a promise? So remember, we're going to call the promise constructor, and we're doing so by passing it as a parameter the function that initializes the asynchronous action. That action is called and passed two arguments, which are functions themselves that you provide that are the success and failure calls you must implement. Your success and failure calls will be passed any data that's required to them by the promise. So you can actually create your own promise just to see how this works. So what I'm doing here is actually creating a function called myPromise. It's similar to how you would create fetch would return a promise, or in that case where we were getting the text back from the response, that method in the JavaScript libraries would also return a promise. Here I'm just creating my own. This is my own promise. It's Brian's promise. So this is similar to, you could imagine, fetch here, right? Like if we were actually building the JavaScript APIs for the fetch method, you could imagine that we were creating fetch here and we were passing it a URL. But we're not. We're going to create my promise and pass it a URL. My promise returns a new promise. So this is, remember I said that fetch returns a promise and that getting the text out of the response returns a promise? Well, they would have the same exact code inside them as well. So I return a new promise, and I expect that I'm going to have a function of two functions passed in, succeed and fail. So these are going to be replaced with the functions that are given to me by the user, and I can then check whatever conditions I want to decide which one of these functions I might call. So in this case, I'm going to look at the URL you passed me, and if it's /Brian, I'm then going to just create this content variable, and I'm going to put in a string delivered as a promise plus URL. So I'm taking this and adding it to it with concatenation. Then I'm going to call your succeed function that you give me. I don't know what it is yet. You're going to give it to me. And I'm going to pass it the content that I created here. So if you wondered where the response was coming from and where the data was coming from in the previous examples, this is how that works. The promise itself is making a decision, right, on success or failure. Once it makes that decision, it calls the correct function. So let's assume it succeeds. It calls the success function that I had passed in. Whoops. Once it calls that, it passes it as a parameter whatever it wants. So that could be the response. It could be the text within the response. Otherwise, it calls my fail function. In this case, I'm not creating anything dynamically. I'm just going to pass it some text saying so sorry. Let's see what it looks like now when we call our custom promise. So here I am creating it with just object syntax. So new promise, and I pass it /Brian. So now I alert. Well, if you remember back when we created it here, if the URL was /Brian, and it is in this case, that means that we ran this bit of code. So we created this content variable and we called succeed. And what did we get back? Well, we got back this object promise. Why do we think that is? Well, just like any other object, right? We haven't actually called on it to give anything to run, right? We need to give this a success and we need to give it a failure. So let's look at that here. So we have our promise now, and we know this is going to be returning a promise, and then on it we're going to call the then method, pass in our success and our failure methods that we're defining. We know that the promise is going to return to us some data. We know in the failure here it's just going to be the so sorry, right? But in the success here, it's going to be that variable that we created that was the concatenation of the delivered as a promise and whatever URL I sent it. And you can see, in fact, that that's what happens here. It runs my success function, which it should, because it was /Brian. That's what the promise looked for. It then alerts that data, which is delivered as a promise /Brian. And if we called it with not Brian, we would then receive so sorry. All right, so how do we call a fetch with a post? All of the examples we've used so far were get examples. Let's explore a post. That is actually a pretty important one that is used all the time. We still have a fetch and we still have the URL that we want to call. But now we're going to add another parameter. The next parameter are the headers that are going to be sent with this request. If you're just doing a get and you don't have any headers to declare, like a cookie or something like that, you can just send the URL. You don't need to include the headers at all. It will set them up as default. Since a post is not default, default is get, we need to include the headers in order to send the post. So we have the URL, comma, second parameter here, which is all of this, I should say, is the header. So we have our HTTP method is post, And then we have additional headers. We're going to set the content type to application JSON because we intend to send some JSON. We're also defining the character set as UTF-8. Now, within here, we have the body as well. So another comma for a third parameter. So we have URL, headers, and body. The body is the actual contents, which, because this is JSON, we're just sending here a JSON string. The JSON string we're sending just simply says profession and gives some value. So what would this be analogous to? If you were going through your setup screens in your game and the user selected a profession that they wanted to be, say they clicked on farmer or pressed, I don't know what number, but number 2 for farmer, then you would take that value, and this is how you could send it back to the server to save the user's progression through the screens that they've selected a profession. You can take that little bit of data that you need to respond to the server with, package it up as a JSON snippet, send it to an exposed API, and now the server side will receive that request, save the information so we know that they are now a farmer, and it would then return a response. What happens to the response? Same thing like before. This fetch will return a promise. We then use the then method on that, and we give it a success function. Our success function here will be passed, just like before, the response that came back to the promise. We check the response to see if the status isn't 200, and if not, we log it. Otherwise, we just return, because here, all we want to do is just say this is saved. There's not really anything to do here because it was a save, it was a post, right? You might have something on the client side to do, but very commonly on the client side, when you save something, there isn't actually anything to change. Usually a GET request will result in something changing on the client side. A POST request usually results in something saving on the server side. Now, that said, you should always field the response. If you don't, the client can become confused. It can wonder why you haven't tried to field the response, and it might hang. So it is always good form to include, even if it's just a log statement or nothing, to include the then and a success function that happens when this is complete. So what are some problems we might run into with this approach? Well, there is some. So one problem that you might have experienced yourself on dynamic sites is the back button problem. On a standard site, the back button will work for every single piece of history you go through on a website. If you go from page A to page B to page C to page D, all of those will be in your history, and you can go back from D to C and C to B and B to A. But in an asynchronous world, this is not going through the browser. We are using either the fetch API or the XMLHttpRequest API, and these APIs do not log the changes through the window mechanism that actually saves it to history. So if you hit back, nothing is recorded. Now, you can actually manually do that with JavaScript. You can update history yourself. So this is something that it is possible to fix, but you have to be careful because an asynchronous action is not always the same as a page load, and it probably shouldn't be treated that way. But it's something to be aware of. Users instinctively want to use that back button to go back through their kind of historical steps, and you need to be cognizant of when that should be allowed for them and possibly when not. Another issue you can run into is network latency. So network latency is obviously going to be a problem anytime your network is slow, but if you're doing many asynchronous requests, it can definitely make this more exacerbated. A user who's using a dynamically driven site may not understand why the site has ceased working, even though the page is loaded and they can see everything on the screen, but all of a sudden nothing's responding to their clicks. There's also the possibility that this wouldn't work in a browser. Now, this is rare today, but you have to keep in mind that in world of Internet of Things, you can have people with like an old Garmin watch like I have, and that old Garmin watch just doesn't support AJAX. So just because modern phones and tablets would, doesn't mean that your refrigerator and your watch do.